Okay, so think about that cup of tea you have. Maybe it's first thing in the morning. Maybe it's, an afternoon ritual.
That comforting moment.
Exactly. You're focused on the warmth, the taste, maybe the caffeine kick.
Mm.
But what if brewing that tea was actually cleaning your water a little bit?
It sounds surprising, doesn't it? But there's some compelling research from Northwestern University suggesting just that. They found brewing tea can help remove heavy metals, things like lead, cadmium from drinking water.
Right. Lead and cadmium, stuff you definitely don't want.
Hmm.
So how does that even work? It's not like the tea dissolves them.
No, not at all. It's a process called adsorption. Think of it like tiny bits of metal, the ions, getting stuck onto the surface of the tea leaves.
Like little magnets that just cling on.
Pretty much, yeah. They adhere to the surface and get trapped there. It's a passive thing, just happening while you brew.
Huh. And this research came from Vinayak Dravid and Benjamin Schindel at Northwestern.
That's right. Dravid's actually an expert in these kinds of materials, sorbents that grab onto things, but they were clear. This isn't about saying, throw out your water filter and just use tea bag.
Okay, important clarification. So not a primary filter replacement.
Definitely not. But what Schindel highlighted, and I think this is key, is just the sheer volume of tea people drink worldwide.
Billions of cups, probably.
Exactly. So even if the effect in one cup is kind of small, multiply that globally, day after day. It could actually add up to a meaningful reduction in exposure for populations.
Right. A small percentage drop, but across millions or billions of people could maybe influence public health trends over time.
That's the potential implication they're pointing towards. It's quite thought-provoking.
So let's get into the nitty-gritty. How did they figure this out? What did the experiments actually look like?
Well, they started by creating water samples with known amounts of lead. They also added other metals like chromium, copper, zinc, and cadmium to get a broader picture.
So controlled contamination levels.
Precisely. Then they heated the water, just like you would to make tea, and steeped different kinds of tea in it.
What sorts of tea? Like black tea, green tea?
Yep, black, green, oolong, white. Even some herbals like chamomile and rooibos. They steeped them for various lengths of time, too.
Mimicking real-world brewing.
Yeah.
And the key measurement was?
How much of the metals were left in the water after steeping? The difference told them how much the tea had absorbed.
Okay, makes sense. Did they look at tea bags versus loose leaf? Because, a lot of people use bags.
They did, and this was actually one of the more surprising findings. They tested empty bags, cotton, nylon, and cellulose ones.
Huh?
The cotton and nylon bags, they barely absorbed any metals at all, negligible amounts.
Really? So those materials don't do much in this regard. What about cellulose? That's the papery kind, right?
Yes, the plant fiber-based ones, and those were, interestingly, quite effective. They absorbed a noticeable amount of the metals.
Huh. Why would that be?
Schindel suggested it's likely down to surface area. Cellulose fibers probably have a much more complex, larger surface area compared to the smoother synthetic fibers of nylon or cotton.
Ah, back to adsorption. More surface, more places for the metal ions to stick.
Exactly. More real estate for the adsorption process to happen.
That's actually good news, isn't it? Since most tea bags are cellulose now, and people have concerns about microplastics from nylon bags anyway.
Right. It seems the more common biodegradable option might have this added benefit, plus you avoid the microplastic issue potentially linked to nylon when steeped in hot water.
Okay, so bag material matters. What about the tea inside the bag, or if you use loose leaf? Did, say, black tea work better than green tea?
The actual type of tea, black, green, oolong, it played a role, but it was relatively minor compared to other things. Same with how finely ground it was.
Oh, I might have guessed grind size would matter more.
Well, it did slightly. They noticed that finely ground tea, especially black tea, absorbed a little bit more.
Why black tea specifically?
Again, likely surface area. The processing for black tea, that whole wrinkling and oxidizing process, seems to create more pores and texture on the leaf surface. Grinding it finely just increases that exposed area even further.
So more processing, more grinding equals more little nooks and crannies for the metals to latch onto.
That seems to be the idea. More available binding sites. But like I said, tea type and grind were less important than one other factor.
Okay, what was the big one? Let me guess. How long you let it steep?
Bingo. Steeping time was the most significant factor they found. The longer the tea was in contact with the water, the more metals were removed.
That makes intuitive sense. More time for the adsorption process to actually happen.
Exactly. If you just dunk the bag for, 30 seconds, you're probably not getting much of this effect.
Right. But if you let it sit for a proper few minutes...
Or even longer, like people who make iced tea by steeping it overnight.
Oh, yeah. That would give it maximum contact time.
Definitely. The researchers noted that longer steeping leads to much greater removal of the contaminants. Short brewing times, minimal effect. Longer times, much better results.
So can we put some numbers on this? For a typical brew, say 1 bag, 1 mug may be brewed for 3 to 5 minutes. What kind of impact are we talking?
Their estimate, based on the experiments, is that a typical brew like that could remove around 15% of the lead.
15%. Okay. And that was even when the lead levels were pretty high, right? Up to 10 parts per million.
Yes, they tested at those higher concentrations. And while 15% might not sound like a huge number on its own,
If you drink several cups a day, or if it works similarly at the lower lead levels, more commonly found in tap water.
that's the thinking. Schindel suggested the percentage removed is probably similar even at lower concentrations. The limiting factor really seems to be the steeping time, how long the tea has to do the adsorbing.
So it's not like it gets overwhelmed easily. It just needs time.
Seems that way. And even a consistent small reduction, like 15%, cup after cup, day after day, across a whole population.
Could potentially lead to lower overall exposure and maybe fewer related health issues over the long term.
That's the potential public health angle. It's not a solution for, say, a major lead pipe crisis where you need serious intervention, obviously.
No, absolutely not. It's not a replacement for proper water treatment in high-risk situations.
But in places with maybe low-level persistent contamination or just as a general background effect, it might be offering a small, consistent benefit that we haven't really recognized before.
Could it maybe partially explain why some populations with very high tea consumption sometimes show lower rates of certain illnesses? It's a long shot, maybe, but
It's a hypothesis the researchers themselves floated. Could this widespread tea drinking be an underappreciated factor contributing to public health, especially in areas where water quality might be variable? It's certainly plausible.
it all comes back to that surface area, doesn't it? The tea leaves, especially processed or ground ones, and those cellulose bags just offer a big, sticky surface for metal ions.
Precisely. Like using a bigger or stickier magnet on your fridge, more chance for things to attach. It's a physical trapping mechanism.
So the big takeaway here is that simple cup of tea you enjoy might be doing a little bit more than you thought. Beyond the flavor and the ritual, it could be passively reducing your intake of certain heavy metals.
Yeah, it's an unexpected bonus, potentially.
Yeah.
Makes you think about your own brewing habits, maybe letting it steep just a little bit longer.
Definitely gives you something to mull over next time you put the kettle on. And it poses that bigger question, right? Could this incredibly common global habit, drinking tea, actually be playing a subtle but significant role in public health, especially regarding water contaminants?
It's a fascinating question. It shows how everyday things can have these hidden connections to our health and environment. Something we do without thinking might actually be interacting with our world in complex ways.
A lot to steep on indeed.
Mm.
Click like and subscribe to the Unlock Your Mind channel.